Yeah. Um, so, Implementing cybersecurity is very difficult today because of the vast majority of devices that we have. In fact, there are more devices on the planet than there are people, and the attackers are becoming more innovative. As there are more devices, there are more ways to get hacked. So, to implement cybersecurity, it is very essential to know how hacking works because you need to know how the attacker thinks to build proper defenses for your systems. Cybersecurity in general is a very broad topic. It has a lot of fields under it, like cryptography, which deals with making our messages unreadable to an outside person. And then there is something like web exploitation, where you target websites and web servers in general. Then there are topics like reverse engineering, where you basically reverse engineer a program and crack it so you can so basically, where you see all the cracked versions of games and movies, at the end of the day, they were reversed. And then there is binary exploitation. Binary exploitation is a type of uh, hacking that you do on binary files. So we'll get more on how or what a binary file is in the coming slides, and the entire course will be on binary exploitation. So essentially what binary exploitation is if you have a program, if the programmer was not very careful while making the program, and if it has any security vulnerabilities, we can hijack the program and make it do something that it was not intended to do, and exploit it to our advantage. That is the essence of binary exploitation. There are various methods to deal with binary exploitation that you will be learning about in the future sessions. Okay, so now we'll talk about Linux. What is Linux? Linux is basically an operating system that is based on the Linux kernel. It was released by this person named Linus Torvalds, um, and he started it as a hobby project. So, what is an operating system kernel? An operating system kernel is like the central part of an operating system. Uh, it is what um, communicates between the system's hardware and software resources. You can essentially think of it as the bridge that talks between your hardware and the application that you use. Okay, so Linux as an operating system is typically packaged as a Linux distribution, which includes the kernel and the other supporting software and libraries, so that it becomes a useful package for the end user. Um, there are many distributions or distros of Linux, and some of the most popular distros are Ubuntu, Fedora, and Arch. Okay. Um, okay, so the most used general purpose operating system of today is Linux. Most of the web servers or supercomputers mostly use Linux. And the reason why Linux is the most used operating system is mostly because of Android. Android is built on Linux. Android uses the Linux kernel. Okay. Okay, so now how is Linux different from Windows? Linux and Windows are two separate operating systems. They are completely different. Linux, on one hand, is free and open source and is regularly maintained. But Windows is closed source and it's not free at all. You have to pay for Windows. And it has Linux has way less specs compared to Windows or Mac OS, which makes it a better choice for most people, including us, hackers. So, what do you mean by open source? Uh, Linux being open source basically means that anyone in the world can look at the source code of Linux and propose changes to it, or cooperate onto their own system and then start working upon it as their own project. So people can use Linux, people can contribute to Linux, people can make Linux better. But the same cannot be told about something like um, Windows, because the Windows source code is only available to the people working in Microsoft. So Yeah, so Windows is closed source and Linux is open source. There are many advantages to using Linux. Like you can configure your Linux machine in any way you want because there is no corporation or company that is putting any constraint on you or what you can do with your system. We also have a huge amount of users and a huge community where you can always get help on forums. One advantage of Windows would be that Windows usually has a greater amount of software that you can use. Uh, Things like Adobe products and games. Most games these days, like Fortnite or Valorant, they don't get released for Linux. They get exclusively developed for Windows and sometimes Mac OS. Not always, but sometimes Mac OS. This is basically because most of the people in the desktop uh, computing scenario always use Windows devices. The market share of Linux in personal computing is very less. I think it is below 5%. So people prefer Windows because Windows generally has a lot of proprietary software like Adobe products and games and such software. On to the next slide. Okay, so uh, now we'll talk about the terminal. What is a terminal? Terminal is the heart and soul of Linux. It is something that you can use to um, communicate with your computer. Uh, it is basically uh, it is basically an interface where you can connect to your computer without any graphical user interface. So why you do? I'll show you how what the terminal is and how it works in a second. So, but why do we use a terminal? There are some things which you can get done faster using a terminal. For example, there will be some very specific things that you have to do that that takes a lot of time when you want to do it through a graphical user interface. Or say you want to connect to a web server or a highly busy supercomputer. You cannot always connect a monitor to it and expect uh, expect you to have a graphical user interface at all times. So this is why we need a uh, terminal. This is where you mostly use a terminal. Terminal also allows you to become more efficient. Once you are familiar with all the Linux commands, the terminal a very efficient way and mostly faster than
There's a slight network issue. We'll connect back. If you have any doubts, you can raise hand and ask in the chat. Else, you can ask in the Q&A session, or you can ask it in the general chat also after the session or whenever possible.
I sorry for the break. There was a network issue at my end. Okay, so now we'll look at some uh, Linux terminal commands. Um, So these are the Linux commands that will be covered in this session mostly. We'll also talk about some other Linux commands if we get the time to. Um, so don't worry about the slide. We'll look at all of these commands in detail in the next few slides. Okay, we'll also need to know what a flag is. Um, please put your messages in the Q&A section if you have some doubts. Because, and the other people will be responding to your queries in the Q&A section. Any Linux distro is fine, by the way. It doesn't matter what you use, or a VM. You can use a VM also. And yes, the recorded session will be available to all of you. Okay, so what are flags? Flags are basically the options that you give to a Linux command. It enhances the functionality of the commands that you can use. So we'll move on with the next slide. Okay. So the first Linux command that we will see is uname. This command will display all the system information, including the kernel name, network node host name, kernel release date, kernel version, and other stuff. So I'll open up my terminal. So the thing you can see on my right side is my terminal. And anything I type here, I can type in commands, I can type in anything that I want. Okay, so I'll run uname. As you can see, running uname just gives me Linux. It's the name of the kernel. So the, to get more information or to know more details about my system, I will run the command uname -a. And this A is the flag to the command uname. And what A stands for is it gives us all the information. So running uname -a gives me all the information about my system. As you can see, my kernel is Linux and my network node name is Shadow Machine. And this is the version of my Linux kernel. And you get a lot of other information as well. So this is the first command that we'll see, and this is a very useful command to know what kernel you're running, what kernel version you're running, and other information about your system. Now, how do you know what flags to use and which flags cater to your needs and what any flag does? So most of the Linux commands have a manual page, and you can access these pages by running the command man uname. So running man uname gets us to the manual page of uname. And this is exactly what it sounds like. It's a manual to the command. You can get all the flags that you can use for all the different functionality. For example, right here, you can see A stands for all, and it prints all the information uh, in the following order. So you can see first it prints the kernel name, then it prints the node name, then it prints the kernel release, kernel version, and stuff. So suppose I just want to know the node name. So what I do is I'd run uname -n. So let's look at what uname n does. So uname n gives us the name of the network host name. Again, running man uname, you can see more options. So -v gives us the kernel version. Trying it out. Gives us the kernel version. Okay, so I hope every one of you understood what uname does. Uname essentially gives us information about our system. That is all that uname does. Now we'll move on to the next command, that is pwd. Uh, what does pwd do? Pwd stands for print working directory. It is so in Linux, directory basically means the folder that you are in right now. So print working directory basically returns the directory that you're in right now. So right now I am in the summer school directory, and to confirm this, I'll run pwd. So running pwd gives me the full path name of the current directory. as you can see, I am inside home. I'm inside my user folder, Abhinav, and then I'm inside the folder summer score. So that is what PWD does. Additionally, we can look at the manual page of PWD. Running man PWD gives us the manual page, and obviously there is not a lot of options that you can use because PWD is a very basic command and it does not do anything other than print the name of the current working directory. Okay, we'll move on to the next slide. Okay, the next command that we'll look at is ls. ls basically lists all the contents in a directory. So if you need to know what is there in a folder, what files are there, what are the names of these files, you would use ls. So running ls on my summer school directory gives me all the files that are there in the folder. So there is a file called a.out, there is a C program file, and then there is a hello world.c, and there are two random files. And you can see that the folders are colored in blue. So any blue colored thing basically means okay. Yes, that was my network is a little bad right now. So okay, so I was talking about a common flag that we can use with ls, that is lsa. So what lsa does is LSA lists all the files inside the directory, including hidden files. A hidden file is basically something that has a dot at the beginning of its name. and it is not usually visible when you run or open. If I had not configured it, especially it would not show. Um, yeah, so what a hidden file is a hidden file has a dot at the beginning of its name. So it basically is not visible when you run something simple like a normal ls command or if you open it in a file explorer. ls minus a lists all the hidden files and hidden directories. So as you can see in my current directory, uh, there is a hidden. I have both a hidden file and a hidden directory in this directory right now. Okay, so now we can move on with the next command, that is cd. cd stands for change directory. You can replace directory with the name or the path of the directory you want to navigate. cd is used to change directories also. uh, Currently, as you can see, I am in summer school directory. So say I want to go into dir1. So what I would do is I'd type in cd dir1. So now I am inside directory 1. Uh, and then you can run ls to know that there is another directory inside dir1, that is dir2. So all that cd does is cd change the directory from where you are right now. Okay, so now there are certain patterns that you can use with cd. Suppose you use two dots. Two dots stand for go up one directly. So cd dot dot slash would take you back to summer school because currently you are in directory one or dir one for short. So running cd dot dot slash gets us to summer school, and dot stands for the current directory. So suppose I were to type in cd dot slash dir two. So what this would do is it would find dir2 in the current directory and then change my directory to dir2. So Sorry, dir1, because there is nothing called dir2 here. Okay, so running dot slash dir1 basically moves us to dir1. Another option that you can use with CD is minus. So CD minus gets us to the previous directory. So running CD minus, we go back to summer school because summer school was the previous directory that we were in. Okay, now we can look at another option called tilde. So now when you run CD tilde, it takes us to the home directory of my computer. So running this, I go to home. So now you can run pwd to see that I'm in home/admin. Now I can again go back to CD summer school. Okay, this is what CD does basically. Now we can look at the next slide. The next command that we'll look at is mkdir. So mk directory makes basically stands for make directory. So it creates a new directory. So it's a very basic command. So I'll show that. So as you can see, by the way, the command that I ran in between is clear. Clear basically clears your entire terminal and gets you a free terminal that is clear. So basically running clear gets me a fresh terminal. Okay, running ls, I can see that the only directory that is there in my current folder is dir1. So suppose I were to make a new directory called new dir. So mkdir new dir would basically make a new directory. Running ls again, you can see that there is a new directory that is created. That is the use of new directory, make directory. Okay, now we can move on to the next command. The next command that we'll look at is touch. So touch in Linux is used to create a new empty file and to change file timestamps of existing files. So what I mean by this is suppose you want to create a file but do nothing with it. Suppose you would want to create a new text file and then you would want it to be empty. So you would basically do touch new text file and a new text file would be created. As you can see, when I run ls, I can see that there is a new text file in my directory. That is the new text file. I can also look at the time at which a file was modified using the L flag of ls. So let's do ls-l. Running ls minus l gets me ls, but it also shows the timestamps at which each file was changed. Okay, so as you can see, this new text file has a timestamp 1540 because that was the time at which this was created. Suppose I'd want to update the time of something like a.out. Running touch a.out should change the timestamp. As you can see, it does. It basically does nothing to the contents of the file, but it changes the timestamp, or if the file does not exist, creates a new file. Okay, now we can look at the next command. The next command that we look at is move. Move or mv is used to move files. It's just to move a file. So the way in which you use this is, suppose I want to move, as you can see, I have this new text file that is inside summer school. What if I want to move a new text file into Noodle? What I would do in this scenario is I would type mv space and then I would type new text file and then I would move it to new directory slash new text file. So what this does is it takes new text file and then it moves it into this. So running this, you can run ls again, and then you can see that there is no text file right now in the summer school directory. So now I would go into new directory. Now I can see that new text file is present inside new directory. Move can also be used to rename a file. So you can move new text file to old text file. So what it does is it takes new text file from this directory and then it moves it into old text file. So it is basically equivalent to renaming the directory. Running this, you can run this that text file. So move is basically used to rename a file, or it's basically used to move a file. You can also move to rename. Um, Now we can move on to the next slide, I guess. The next command that we'll look at is rm. Rm, as you can guess, stands for remove. The rm file, rm command lets you delete a file or a directory while passing its name. Running rm on Linux machines is not safe because unlike Windows, you're not going to get a confirmation message asking, do you want to delete this file? There is nothing called a recycle bin where you can go and undo your mistakes. So if I run rm old text file, it's gone. You cannot get it back. Once you run ls, you can see that old text file is gone. You can use the flag d to remove a directory. So as you can see, I am inside new right now. To go to summer school, I would run cd dot dot slash. Cd dot dot forward slash gets me into the summer school directory. Now running ls shows me all the folders and files that are inside summer school. Now, say I wanted to delete the directory nuder. So what I would do is I would do rmd nuder. This would remove the entire directory nuder. So running ls, you can see that nuder has been deleted. RM is a pretty easy command. It just deletes. That is the only thing that it does. There are a lot of flags that you can use with RM. We won't get into that right now. You can look at the man page of RM to know all the different flags that you can use with RM. Okay, so now the next command that we'll look at is file. How is file useful? So basically, if you have a file and you don't know what it is, there can be different types of files. You can have text files, you can have images, you can have MP3 files, you can have video files. So file command basically lets us know what type of a file it is. So I'll clear my terminal. I'll do ls. You can see there are two random files in my directory that are random file 1 and random file 2. Suppose I want to know the type of or what kind of a file a random file 1 is. So what I would do is I'd run file and then I'd run random file 1. So as you can see, this returns ASCII text. So it is nothing but a text file. It contains text data. That is the only thing that is there in random file 1. So I could do the same thing for random file 2. Suppose I ran a file random file 2. So you can see that random file 2 is a JPEG file. It is an image file. Um, yeah. So as you can see, this is why you would use file. Um, Moving on to the next slide. Cat. Cat is a very useful command. Cat basically reads files and then displays the content onto the terminal. So suppose, as you can see, I have a file, random file 1, in my current directory that has ASCII text. So if I wanted to view that text directly on the terminal, I would do something like cat random file 1. So as you can see, it prints out the data that is inside random file 1. So Cat basically does only that. It takes a file, prints the contents onto the terminal. That is the only thing that cat does. Um, so we can move on to the next command. The next command that we look at is less. Less is a terminal pager program that we basically use less when some file spits out a large amount of data, and then you want to view it systematically in one screen at a time. That is when you would use less. Less is not that important to us right now. Just know that you would basically use less when there are a lot of data inside a file, and then you want to look at it in a organized way, one page at a time. Um, okay, so these are basically all the Linux terminal commands that you would come across. These are the basic Linux commands that you would use. Now we can talk about binaries. What are binaries? So when you program or when you make a program, you write everything in the programming language that you know. For in our case, suppose we write some code in C. So the computer definitely can't understand C. So what we do is we compile these code. We'll talk about compilation in the upcoming sessions. So what it basically does is it converts everything into binary. A binary basically means ones and zeros, and it is something that your computer can understand. So any program that has to be run at the end of the day becomes a binary. And a binary package is an application package that contains executables. Uh, so think of it as a program, and you cannot run what is inside you cannot read a binary, you cannot understand it. It's basically ones and zeros. So, and a binary is created after you compile a source code, and then we'll talk about these source code and compilation in a future session. Moving on to the next session. We'll moving on to the next slide. We'll talk about C programming. Um, uh, what is C? I'm sure most of you have heard of C as a programming language. C is a general purpose programming language created by Dennis Ritchie in 1972. It is one of the most popular languages in the world. C is very fast, and as compared to other programming languages like Python, C is very fast. And most of you would also have heard about C++. And how is C different from C++? Basically, C++ was developed as an extension of C, and both languages have almost the same syntax. The main difference between C and C++ is that C++ is an object-oriented programming language. It supports something called classes and objects that we won't get into right now. Okay, let's move on to the next slide. Okay, now we'll look at a very basic C program, hello world. So what this program does is it prints hello world onto the terminal. So explaining this, basically the first line is hash include stdio.h. Stdio.h is a header file. It lets us, it's basically a library. Uh, it basically lets us use library functions such as printf, and it lets us, and functions like printf or scanf lets us work with input and output. So std has basically lets us this line int main. So int main basically this is a function. When any program when any program starts, the first code run in the function is inside what is inside main. So if you have a program with a lot of functions and you run this program, the first uh, instructions or statements that are run are from main. So that is the importance of the main function. Okay. Now the next line, printf. Printf is a function that is used to output or print text onto the screen. So now I'll show how you can run this program. So if you look at my uh, summer school directory, just a second.
There's an issue with screen sharing. He'll be right back.
Yeah, so as you can see, there is a hello world program inside my home directory. You can run cat to look at what is inside hello world. So it is basically a basic hello world program. So so You can compile a program using the compiler that is GCC. So running, you can do GCC hello world.c to any basic C program. So running GCC hello world.c compiles the program, and you can see now that there is an a.out file on our home directory. So this is the binary. So how you would run a binary is you would do /a.out. So this basically runs the binary a.out. As you can see, it prints out hello world. What we can do while compiling is you can do gcc hello world.c, and then you can pass the flag O, and then you can rename the output file to whatever you want. Suppose I want to name it as program. So now you can see that when you're on ls, you have a file called program inside the directory. So doing /program basically again prints out the hello world. So this is what the basic hello world program does. We can look at the next slide. Now we look at what are C variables. Variables are basically containers for storing data values like numbers and characters. So basically you would store numbers inside an integer, or you can use float. Floats are used to store decimal numbers, or you could use car. Car stores single characters such as A, B, C, or whatever. So opening hello world.c in a text editor. Vim is a text editor that you can use in the terminal. So running Vim with hello world.c lets you edit any file on the terminal directly without opening another application. So running Vim hello world.c, we can make a new variable. Suppose we want to declare a new integer variable. So I would first have to specify the type of the variable. In my case, it is an integer, and then I will call it first variable, and then I can either give it a value or not give it a value. So in this case, I would give it the value 10. So now I have declared a variable that is my first variable, and it has the value 10. So now this is the basic syntax of defining a variable in C. Okay, so now let's look at how we could print this variable onto the terminal. So we would again need to call printf, and we would write my variable is %d, and then we put first variable. Okay, so what is this doing? So what this is doing is %d is something that is called as a format specifier. So whenever the printf finds a %d, it puts the value of first variable inside this %d, and %d is the format specifier for an integer. So whenever you need printf to put the value of an integer inside the string, you would use a %d. Okay, so now we can try compiling and running this program. Again, we can compile this using GCC. We'll do GCC hello world.c, and then with the flag O program. So it names the output file program. So our final binary is program. Compiling, you can see it compiled without any problems. You can do /program. You can see hello world, and after hello world, my variable is 10 got printed. Okay, we can again open this up in Vim. You can see that hello world and my variable is %d got printed in the same line. Suppose we wanted our program to print these two lines in a different line. So what we can do is we can go here, and then we can put something called a backslash and an n. A backslash n is basically a new line character. So what it does is it opens a new line after it prints hello world. Okay, to check if this works, we'll go back to our terminal. Then we'll compile it again, and then we'll run it. you can see that my variable is pen got printed in the next line. Okay, now we can look at some different uh, format specifiers. So the format specifier for integer is %d, and for a float is %f, and for a car is %c. And there are some other format specifier in here as well. You can look them up. You can look at what these data types are and how they're different from integer. We won't get into any of that right now. Okay, so I can also show you how you would define a character. So opening this up in Vim again, we can define a character variable. This would be my second variable. And then you can equate it to something like, say, Z. And then since we want to print this out, I put a slash in after this because I don't want this to be printed in the same line. Then, and again, I printf. My character is, in this case, I'd use %c because my data type is a character. Then I'd do slash n, and then I would pass the value of my character. Exiting from Vim again, we can compile and run. As you can see, I defined two variables. I defined an integer. I defined a character. Both got printed out onto the terminal. Okay, now we can look at the next slide. Okay, now we have looked at some of the basic uh, uh, variable definitions, or how you can declare a variable in C. Now we look at something called an if-else statement. Um, okay, so what if we want to compare two variables? Suppose I have another variable. I have one variable A and that is equal to 1, and I have another variable that is equal to 2. Let's remove all this. And then I want to see if A is bigger or B is bigger. So what I would do is I would have an if-else statement. So what I would do is I'd say if A is greater than B, and then the syntax is to have curly braces and put whatever you need to type inside these curly braces. Then you would type whatever you want to do here. So if A is greater than B, I want my program to say A is greater than B. And then I would put a slash in here. And if A is not greater than B, then I want it to print that B is greater than A. Again, we can we can compile this. Now it has generated our binary file program. Then we can run the binary. So you can see that we printed out hello world, and then we printed out that B is greater than A. Okay, now let us go into this again, and then let's talk about else if. Suppose we had A is equal to 1 and B is equal to 2. Instead of that, let's make A also 2. So now both of this would be wrong because let's run this. What would happen is it says B is greater than A, but B is not greater than A. We can fix this in two ways, but I will show you the use of else if conditions. So we can do else if B is greater than A, you could say this. Else, you could say both are equal. Again, we'll compile and then we'll run. You can see both are equal. Okay, so that is how you could put an if or a for else if or an else. This is how you would use an if else statement block in C. Okay, now we can look at something called a for loop. What is for loop? Basically, what a for loop does is I will write the basic syntax for loop. For int I is equal to 0, I less than equal to 100, I plus plus. Okay, so let me tell you what this does. Basically, what this does is it initializes the integer I to 0, and then it goes on till I is less than or equal to 100, and then it I plus plus increments I by 1 after each loop. So I can do something inside this loop. Suppose I want to say I is currently set to, then I put percentage %d because it's the format specifier for an integer. Then I put I, then I put, of course, I need to put a slash in. So what this program does is it goes into this loop. It initializes I to be 0. Then it goes on until I is less than or equal to 100. So the moment I becomes greater than 100, this for loop stops, and then I gets incremented by 1 each time. And then for each of these iterations, it prints I is currently set to percentage %d, and then it takes the value of I and then puts it inside here. So for each iteration, it basically prints the value of I. Okay, so now we can compile and we can run. As you can see, everything happened really, really fast. So for each iteration, we got I from 0, and then we went on till I set to 100. So this is one very basic way of how you would use a for loop. And then we have another type of loop, and this is called a while loop. So how is it different? Opening this thing up again in Vim. The same thing you can achieve by using a while loop. Okay, let me remove all this. Yes, now I can put a while loop. So you can say A and B are already declared here. So I can say while A is less than, let's say, 100, keep doing this. So this loop gets executed while A is less than 100. So until A is less than 100, this keeps happening, whatever I write inside. So if I just wrote printf hello, what would you think would happen? Hello would go on forever, it would never stop because always less than 100. Okay, so now what would happen if I said A is A plus 1? So this loop in each iteration would update it. It would add 1 to A. So until A goes over 100 or A becomes 100, hello gets printed. And once A crosses 100, this while loop stops. So we could do something, anything with this. We could, it basically works. It's just a loop. And the difference between while loop and for loop is you don't have such a big condition as that you would have in a for loop. You could put the condition inside this and you could update the variable manually out here. So I'll show you what happens if you don't update this. So as you can see, I have not updated it. So you would expect this to go on infinitely. Let's try to compile this. It compiles. Now let's try to run this. As you can see, it just goes on. It never stops. And I can stop it by pressing Control and C on my computer. So basically, if something is going on in the terminal and you want to stop that process, you can press Control and C together and then it gets stopped. So this is something that you should take care while writing while loops. You should make sure that this condition will always get exhausted. Otherwise, your program will go on till infinity without doing anything. Okay, so this is something you should always keep in mind while using while loops. So now we have covered while and for loops. Now we look at the next thing. Okay, now we'll talk about memory addresses. What are memory addresses? Okay, so whenever a variable is created in C, a memory address is assigned to this variable. So everything is present in your computer's memory. And so each variable has a specific memory address where the variable is stored. All the variables that we stored, the integers, the characters, everything has a memory address. And when you assign a value to the variable or when you update a variable, it gets stored inside the memory address that is there for that variable. And to access the memory address of a variable, you can use the reference operator, and that is the ampersand. So you can use the ampersand, and the result represents where the variable is stored. So going to our example, we can go to hello world.c, and then we'll remove this while loop because it's not doing anything. Okay, so let's say we wanted to look at the memory address of A. How would we do this? We would basically use the reference operator. So we need to do printf, and then we say the memory address of A is percentage P, and we put ampersand A, and of course we won't have slash n. We'll also put in the memory address of B is percentage P slash n ampersand B. Okay, so what this does is basically it takes A and then it uses a reference operator, and this gives us a pointer to A, and the pointer is basically where the variable is stored in memory. So, and this is the format specifier for a pointer, and we will also print out the memory address of B. So we can exit Vim, we can compile, then we can run. As you can see, we got two memory addresses for A and B respectively. So what are these numbers? It looks like some weird language, but no, this is hexadecimal. So the memory addresses are usually stored in hexadecimal. Hexadecimal is basically a different number system. If you've not heard of it, you can look it up. It is a number system with a base 16. So these are hex numbers, and hex numbers are used to represent the memory addresses. We can go on to the next. Okay, so what are pointers? A pointer is basically a variable that stores the memory address of another variable as its value. So basically, a pointer is something that stores a memory address of something. Suppose you wanted to store the memory address of A in another variable. What you would do is you would create a pointer, and this pointer can store the memory address of this variable. So I'll explain how you could declare a variable. Again, we'll open up hello world.c. We will delete these two printf statements. We will go here. To declare a pointer variable, you would have to do int, and then you would use a asterisk, and then you would put the variable of the pointer variable. So I would name it my pointer. So now, as I've told, you can declare variables without having to put anything to equate it to. You can just declare a variable and then worry about it later. So I'll show you how you would do that. So now I've declared a pointer to the integer, and then I've named it my pointer. Then I will assign the value of my pointer to be the memory address of A. Okay. Now what I can do is I will printf the memory address of, or no, I will do the value of the pointer variable is percentage p, again because the format specifier for a pointer is percentage p, and then I put my pointer. Okay, now we'll try running this. We'll see what happens. Again, as usual, we need to compile, then we'll run. As you can see, you got the value of the pointer variable. Okay, there is one more way in which we can print the memory address, and that is by using referencing. So, the memory address of A is again %p, again /n, and then we'll reference it by using ampersand, and then we'll put A. So now you can compile this, then you can run this. As you can see, the variable pointer variable and the memory address is the same. That is because we assigned the pointer variable to store the memory address of this variable. That is the reason why both are same, and we expect both to be same. So this is the way in which you declare a pointer. Okay, now we can talk about dereferencing. Okay, what do you mean by dereferencing a pointer? So we can, why do we use a pointer? We use a pointer to store or get the memory address of a variable. But what if you want to view the actual uh, data that was stored in the memory address? This is where you would use a reference. So basically, suppose you wanted to, we know that my pointer is a pointer and that it contains the memory address of the variable A. Suppose we are given the pointer and we want to print the value that is contained in that memory address. That is where you use a dereference operation. Okay, so we'll look at how this works. We'll have another printer, and then we'll the value at this location is, then you would use the format specifier for an integer, which is %d. Then we'll not forget about the new line character, and then we'll put an asterisk followed by my pointer. So what this does is it dereferences the pointer and then it gets the value that is stored in the memory location. Okay, we can run this. We can compile this. Okay, so while compiling, we got an error. Why is this? We can read. It expected a semicolon before return. So every line should be stopped with a semicolon. So we'll go into hello world.c again. As you can see, I forgot to put a semicolon here. We'll put a semicolon. We'll clear, compile, then we can run. As you can see, the dereference actually gave us the value that is stored in the integer. That is 2. So this is how a dereference operator works. It can be a little bit confusing, but just think of it in this way. A variable stores a data type that is an integer in this case, and it stores the value of 2. And this is stored in some memory location. And we can access this memory location by using the reference operator. And the reference operator is the ampersand. And we can store these memory locations in special variables that are called pointer variables. To declare a pointer variable of any type, you can type the variable type and then an asterisk, and then you can name the pointer. So now you have declared a pointer variable named my pointer, and then we have equated my pointer to be the memory location of A by using the reference operator. That is what we have done here. So what it does is we've made 3 integer variables. All of these are present in some memory locations that you don't know, and and then we are making a pointer variable. A pointer variable stores the memory location of a variable, and the memory address is saved in this my pointer in this line, and then we are printing the value of this pointer. So value of the pointer variable itself should be the memory location of A. So we would use the correct uh, format specifier for a pointer, and then we print my pointer. In the next printf, what we are doing is we are printing the memory address of A. And then for this, we are using the referencing operator. And again, the memory address would be a pointer type. So we use the type specifier %p. In the next line, we use the referencing operator. No, dereferencing operator. What dereferencing does is basically it takes a memory location, it takes the value that is stored in that memory location. So asterisk my pointer basically gives me the value that is stored in this location, and that should be 2. And as we can see, we clearly get 2 when we compile and run this program. Yes. Okay. Now, on to the last topic that we'll talk about. What are functions? Suppose you have a program and uh, you want to perform a repeated set of tasks multiple times. So instead of having to write it out multiple times, you could write a function and then call this function from within your main or from any other function. So a function is basically something that takes in a value or a lot of values, does some operations on this, and then returns some value. So a function basically is like a subprogram in your program that does a task and then returns some value. So there are two types of functions in C. There are user-defined functions, and then there are library functions. And then the library functions are the functions that have been written by someone, and that are ready for us to be called and used. For example, the uh, uh, library function that we used in our program is printf. Printf is present in the header files standard.io.h. So this stdio.h contains the library function printf. It also contains the library function scanf, and it contains a lot of other functions as well. So what stdio.h is, it is a header file and it contains some of the functions that we use. So now we'll look at how you can create a basic user-defined function. Okay, so a function basically has three things. First, we should decide what type of value it returns. Let's write a simple function that calculates the sum of first n integers. Okay, so how we would go about doing this is the function obviously returns a sum. So the return value is an integer. So integer. Integer means the return value of the function is going to be an integer. And then we can name the function. We would name the function sum of n. And then inside the parenthesis, you can put the values that the function will take in. Suppose we want to find the summation of the first n natural numbers. So you need to take in the integer n. So you would type integer n, and then you would start curly braces, and you would type out the function inside these curly braces. Okay, how would you find the summation of the first n natural numbers? Uh, Obviously, you can use the formula n times n plus 1 over 2, or you can use a for loop. How you would use a for loop is, first, we would declare a variable sum to be 0. This is where we will add our values, and then we will use a for loop. For, and the integer starts from 1, and it must go on till n, and it must get incremented by 1, obviously, and then we'll put curly braces. And then for each iteration, we will update sum with sum plus I. So each natural number gets added to sum. And at the end, what you need to do is we'll return sum. So basically, we have used most of the things that we have learned in this session in this function. What have we done? We have declared a function, and it returns the type integer. The function is named sum of n because it basically calculates the sum of the first n integers. It takes in the value n, which is an integer again, and then it declares a variable sum, and it sets it to be 0. And then we write a for loop, and the for loop, the iteration variable, that is I, it goes from 1, it goes on until n, it gets incremented by 1 at each iteration. Then for each iteration, we update sum with I. And at the end, when this for loop is done, we return sum. Okay, now we need to uh, call this function from within main. What we can do is we can take in the number that we want to, basically we can read n from the user. So what we would use is a function called scanf. So what we can use is we will declare a variable n. We don't know what n is yet, so we won't assign it any value. Then we'll call the library function scanf, and then we'll do please enter. And there's a format specifier. We are reading an integer, obviously, so we'll use the format specifier %b, and then we would put a slash n, obviously. And how scanf works is basically for scanf, you need to put the memory address of the variable. So you would put ampersand, and you would put n. Now, what we need to do is we need to call this function. How would we go about doing that? So what we do is we write sum of n, and then we pass it the value n, and then we need to store this somewhere, right? And then how we do this is we create another variable. We create integer result, and then we say result should be equal to the sum of n. We put this here, and then we put a semicolon, obviously, and then we want to see this result. What do? We again call printf. Then we say sum of first. Then we want to put n, so we'll put %b, because we are gonna pass n here. Natural numbers is, and then we'll pass another integer, which is going to be the result, and then we'll end it with a new line character, and then the first integer has to be n, the second integer has to be the result. We can check if this works. Right. We will compile this program, and we can run it. Okay, so the number that we want to find the sum is 10. Say, okay, 1 second. I think I made a mistake. You don't put this here. Um, okay. See, so what happened is we read n from the terminal. We took the sum of first 10 natural numbers, and then we calculated the value using the function called to be 55. To improve this, what we should have done is we should have put in a printf, and then we should have enter the number for which we wish to calculate the sum. We put a slash in. We can compile, and we can run. Let's put something like 5. So the sum of first 5 natural numbers is 15. So this program has basically used most of what we have learned except for a for loop. and point. So what we did, we declared a local variable n. It was an integer. We called printf. We printed this text onto the terminal. Then we used scanf. What did scanf do? Scanf took an integer and stored it in the memory address of n. This reference operator basically returns the pointer to n. Then what did we do? We made another variable that was called result, and then we stored the value of sum of n in result. And then we had another printf call, and in this printf, what we did is we basically calculated the sum of first percentage d natural numbers, that is the first n natural numbers, and then we returned the result. So we went through a function, we made a function, it returned an integer, we called the function with the argument n. An argument is the value that you pass to the function, and in this case, we read that argument from the user, and then we calculated the sum. So this is a very basic program that you could write in C. Okay, so that brings us to the end of this session. We had a lot of network problems. I apologize for that. I don't know what was going on. So you can ask any questions that you might have.
Hello, am I audible?
Yes.
So if anyone has any doubts, you can raise your hand and we'll give you the permission to unmute. Then you can ask your doubt. I have lowered all the current hands. If you have any doubts, you can raise your hand. We'll unmute you and you can ask your doubt. Okay.
Hi, am I audible?
Yes.
Yes, you are audible.
Yeah. So I wanted to ask about the working of CD commands, but does
Could you
CD
could
dot
you
dot
repeat?
slash?
Your voice is a little bit muffled. Could you repeat that?
Uh, I want to ask about CD commands, CD dot slash and the CD dot slash. What's the difference between these two?
Yeah. So what cd dot slash does is dot basically tells the terminal to do something in the current directory. Suppose I okay. So I'll share my screen here. I guess. Yeah.
So it's like
See.
dot is the okay.
I'll show you. So my current, so I am currently in my summer school directory. So I go into dir1, right? And you can see that there is directory Q inside directory 1. So I can do two things. First, if I do cd dot slash dir2, what would happen? It basically does nothing. It goes into the current directory and then it goes into dir2. So if I run this, I'll just go into dir2 and it's equivalent to running cd dir2, right? And what dot slash does is it goes one directory up. Okay, so once I do cd dot slash, I am currently in directory 2. Once I do dot slash, I go into directory 1. And I can do one more dot slash to go into summer school. Now I'm in summer school. Now, let's say I again want to come back to dir1. So I can type dir1. So what all this does is basically I am in dir2 right now. Dot slash goes one directory up. Another dot slash goes one more directory up. And then we go come into dir1. And dot slash basically does nothing. It says from the current directory, don't go anywhere, just go into dir2. That's it.
Okay, and a few more minutes. Yeah.
Uh,
So can you tell me what is the significance of return zero at the end of a C program? Why do we always write return zero?
Yeah, I think So basically, there is a convention that when you run a program, if you return zero, it basically signifies that the program completed its execution without any errors. So you can basically return nothing from main, or you could return something like 1000 or 34 or some random number. It doesn't matter. But the convention is usually if you return zero, the program executed without having any errors.
I'm really
What is
sorry, I
the
couldn't hear you.
yeah,
Can you please
it's fine.
repeat?
So yeah, basically you can return in, as you can see, we wrote main with integer. So int main basically says that it returns an integer. And by convention, we return zero because by convention, it denotes that the program ran without any errors. You could also return with 0, 30, 40, some random number, it doesn't matter, but it's just by convention that you return 0 because the program executed without any errors. You could also put any return value for me, and you could also not give any return value for me. But it is probably a good practice if you return values for all the functions that you write. Yeah. I hope you could.
Yeah, got it. Okay.
I
Yeah,
don't know
one
if
more
can.
thing.
Yeah, sorry to interrupt. I hope you all can hear me first of all.
Yes.
Yeah, so regarding attendance, so attendance is auto logged by Teams. You do not have to do anything. You just have to attend the meeting and that's it. So for attendance, there's that. Second of all, regarding the choice of language, cybersecurity does not depend on the choice of language at all. There are multiple things that you need to do, and it all in general coalesces into a common intuition that you use to exploit things and basically make them behave in ways that they were not expected to. So yeah, if you don't have any doubts, you can leave the meeting as well. So regarding choice of language, there is no choice of language. You will be instead explaining to you concepts, how a concept works in particular. So we use C because that's the most low level yet human readable enough to explain it. We can also use Go, we can also use Rust, we can choose any other XYZ language and make your lives very hard. We choose C because it's easy for you to understand and for us to explain. So the choice of language comes from that, and no, there will be no C++ involved in this course as such. In fact, after today, there will be no C involved either. We will explain to you in terms of binaries. So I hope this much is clear. So yeah, apart from that, there was a minor mistake in the exit codes. Exit codes on Linux can only range from 0 to 255. I think that's it. Yeah. Zero indicates success. The others are arbitrary, but they all indicate an error.
Yeah, so wait. Others who have doubts, I'll give you permission to unmute and go one by one. Okay. Hello.
Am I audible? Hello.
You're a bit feeble. Can you be louder?
Now, am I audible?
Yeah. You're audible.
Yeah.
Please ask.
Out of curiosity, as we saw the file command, it was giving us the type of the file we have.
Yeah.
So, do files have some bits reserved for the signature that is a TXT file or it is an image file, or do we observe some patterns in the file? Like,
Whatever the command does is it's in the background. Like you don't have to go to technicalities, and even I'm not sure. Like we are not sure about it. So in Linux, like in Linux, the file need not be named by its own extension. Like you can have a text file and still you can put the name as some a dot some jpeg or something like that. But then the file command ensures that it gives you the correct type of file it is. Yeah, so it might use something in the background, but like I don't think it's relevant.
The
Let me
actually
answer that.
the yeah. Okay.
Yeah, Abhinav can go ahead. It's fine.
So basically, you are right when you say that there are so in some files, not all, there is a the initial few bytes of the file or the header contains information on what type of file that is. So, for example, if you have a JPEG file or a PNG file, those are image files. You would have the top few bytes of the file indicating what type of a file that is. So, I believe I can show you that. So, basically, uh, basically I showed you how random file 2 is a JPEG image, right? So I can open this up in a hex editor. A hex editor is nothing but something that lets you view the bytes of a file. You don't need to go into that right now. So basically, you can see these few bytes, this few bytes at the beginning. These denote that the file is a JPEG file or a JFF file, as you can see. And these are called magic bytes. You can look it up. Basically, most files usually have a header that denote what kind of a file they are. I hope your doubt is clear. Not all of them do, but if they do, it makes it easier to identify what type of a file it is.
Yes, sir, it was clear. And in continuation to that, if time permits, uh, sir, as we can see that yes, we have some magic bytes reserved there. So, is there some integrity that yes, if the magic bytes are saying it's a GFG file, then yes, it's a GFG. Is there some integrity, or we can fool the tool?
Yeah, we can fool the tool. I can just copy the magic bytes and then put random information after that. It would still think it's a JPEG file, but when you open it up in a image editor, you wouldn't be able to see anything.
Okay, okay, okay. Thank you, sir.
The next person can ask the doubt.
Hello, am I audible?
Yeah, you're right.
I couldn't understand the calling of the function. Can you just explain once more?
Yeah, just uh, this we call the function, and then sum of n what it does is it calls this function with the argument n. So the program, when it reaches this line, goes in here, and then it equates n to be the value that I've passed, which is basically the input that I've taken from the user. And so this is where you call the function, and the whatever you equate this to gets stored the return value. So I'm returning some. So at the end of the function, the return value gets stored inside result. Does that make it clear?
So sum up and the return sum, that sum value gets stored in the sum of an integer.
Sum is not a function, and you need integer stored the sum. That integer is called sum. Can't, because sum of n is a function, it's not an integer.
I got it.
Hello.
And I yeah, and
Continue.
I have another doubt. So I run a Newton's computer. So how to install Linux? Can you just give a demo? It will be very helpful.
What computer?
It's normal Windows. So how to install Linux? Can you just give a demo?
We'll share a guide in the Teams and the WhatsApp group after the session. I don't think it's possible for us to show that in this time because I think most of us run Linux, so we'll share a guide after the session, definitely.
Yeah, and if you want to just search it up on your own, go and search in Google WSL, Windows Subsystem for Linux. Just go and search that, and yeah, just go through how they ask you to install it, and you can try if you want, and or else we'll share this detailed guide. The WSL is a way in which you can, have the uh, have an idea how, like, it's not fully Linux, it's still running on Windows, but then everything you can experience Linux through it without actually installing it. Yeah, so I think are your doubts done? Can I ask the next person? Yeah.
Yeah. So in this sum of n function, while scanning or taking the input, why have you taken it as reference operator then n? Or why not just normal n?
Have you asked why I put ampersand?
Sorry.
What was your
Uh,
doubt again? Can you?
While taking the asking for the input in the sum of n function, you have passed the variable as reference operator and n.
Yeah.
So why have you used the reference operator before n? Why not just n?
Like it is the syntax. It is how you write it. Like it's
Okay,
the
it's
way that.
syntax.
Yeah, it's the syntax of the program.
Okay, it's syntax. Okay. And while explaining the ls command, you were talking about the names which were appearing in blue. The screen got disturbed back then, so couldn't care about it. Uh,
What?
but what does
The
the blue name mean in ls
okay,
command?
okay. It's simply like some of the things in the folder might be another folder or a file. So in not all terminals, but like if your terminal is like configured or something, then you can see it as different colors. Like he'll show you right now. When he lists everything in his folder, it like the folders will be in another color. But then when you install Linux freshly, when you use ls, you can't differentiate it. That's it. It's not that important. Yeah.
Okay. Just one last thing. If we use cat command with a text file, the text appears in the terminal. But if we use cat with a JPEG or a video file, what will happen then?
you will see random things on the screen.
I'm sorry.
Just show them, da. Just show what. Use random file too. Yeah, you will. Earlier, he was telling about what like the file, what is in the file, like the bytes of the file. Something like that will be blurted out.
Oh, okay. Thank you.
Yeah, so I would like to add one more thing regarding your doubt about scanf, right? So you asked why scanf takes ampersand n rather than just n. That's what you asked, right?
Yes.
Yeah, so when you call a function, so let's say I have a function sum of two numbers, then int a and int b as parameters. And then I do inside the sum of two functions, I do a equals a plus b. All right. But when you call that function, you will outside that function you will still see that the value of a is retained, and that is because in C there is something called pass by value. So when you give the parameters a and b to the function sum of two numbers, it makes a copy for that function of the two numbers. Then it adds them to, and once the function is over, the original numbers stay the same. So now you have to read a number into the variable n, right? How would you do that? So if you pass just a number n, it can't do much because as soon as you exit the function, the value that you read into n will be destroyed. So what you instead do is you pass the pointer to n, and inside the function you dereference that pointer, so that points to the original variable location. So even when you leave the function, the value of n is still changed. I hope I make sense. Is that clear?
Okay, yeah, it makes sense. Just one last thing then. Would
Yeah.
this work if I use N only? Would it still work?
See, it expects a memory location. So when you give the number n, it will read the value of n and assume it is a memory and not an integer. So then it will try. So if let's say right now n is uninitialized, let's say the value of n was initially 1. So it will try to dereference whatever is there at 0x1, the memory location 1. And then it will find some garbage value and most likely your program will crash.
Okay, got it.
Okay, cool. I hope that's clear. Thanks. And sorry for interrupting again.
Yeah. Next person can ask that.
Yes, sir. Is the all sessions going to be completely theory or are we gonna do some practical thing also? Hello.
We are planning that. We'll try to make it more interactive and we'll give you some tasks to try out after the lessons. Like once we give you the guide to install Linux, then you can like install it and try it on your own.
Yes, sir. It would be good to show. I mean, you displaying some demo. We will try. We will also be trying on our laptop. It will be good that way, like doing
Yeah,
something
we'll
instead of just like
we'll
like.
try.
Okay. That,
If anyone else has doubts, they can raise their hand. We'll be open for like 10 or 15 more minutes. Okay, ask.
maybe it would be good to share some resource before joining the session, so we would also be prepared instead of being blank
Hmm, uh, isn't it
beforehand.
better like
If you can share some.
uh, okay?
Hello.
We'll try to see that.
Yes, sir. Because
But
most of the people don't know C. While you are explaining, they cannot grasp what is happening on the go.
no, that's why we are sharing the recording and the PPT after the session. You can go through it at your own pace.
Okay.
It's basically like uh, giving you a class and then giving you the notes after that.
Okay. So that's fine.
Anyone else?
Doubt. Uh, Directory means files or
What?
anything else. Directory means files or anything else.
Directory means another folder. Like yeah, directory is just another folder. It's yeah. What was your doubt? Get it.
Directory means folder only. The folder
Yeah,
in the folder any other things can be there.
yeah.
Okay, thank you.
In Windows, you call it as folder, whereas in Linux, you call it as directory.
Yeah, that's it. Any other doubts? Okay. Uh, yeah.
Excuse me, sir.
You have a doubt?
Yes, sir. Sir, which version of Linux should we use?
We'll put that in the documentation, which we'll share.
Which OS or something we can use in the VMware?
What?
The virtual machine we can run and use.
Virtual machine? I didn't get it.
Yeah, in virtual machine, which Linux system OS we are going to use.
We'll let you know.
Will
We'll send all
yeah.
the
It'll
details
be
in a few minutes.
it'll be
He is
probably
asking that
Ubuntu.
he's asking that he want to install a virtual box, Oracle virtual box. In that, you want to what operating system like a Fedora, which distribution you want to use?
No, that is up to you.
Many
Basically,
distros.
yeah, basically most of the distros like use the basics of all those are same. And for beginner friendly, we'll probably suggest you to use Ubuntu if you have not used Linux before.
Thank you.
Even Ubuntu also somewhat new people, but Zorin will be similar to Windows. It is nothing but Windows. Nothing looks like Windows, but it is Linux. Zorin OS.
I mean, it
You
doesn't
can
really
ask.
matter. We'll be using the terminal for most part anyways, so it's fine.
Yeah, you can ask it out. The person who has raised the hand.
Hello.
Yeah.
I already have installed the Kali Index in my Windows laptop. Is it suitable or I have to change it?
No. If you have installed a Linux system properly, then like the only thing you'll mainly be using is the terminal. So that's literally the same in any Linux distro you use. So if you have
Okay.
already properly installed a Linux distro, it's fine. Just use the terminal over there.
Yeah,
Else we'll
I have been
share.
using it for a little bit ethical hacking. I was learning, so I have installed it
Okay.
before.
Yeah, that's fine. That's fine. Anyone else? Okay, then we'll wind up the session. We'll be sharing both the recording and the presentation in the Teams. So the next session will be day after tomorrow at the same time, 3 p.m. So make sure we'll start the meeting beforehand. Make sure you all join by 3. And any further doubts, you can communicate through the Teams, and you can reach out to us through that as well, or the WhatsApp channel. That's it, right? Yes, sir.
Yeah, I think that should be good enough. We can round it up today.
Okay, thank you everyone for attending the session. See you in the next one.